So welcome everyone. This is the 22nd workshop that the Agricultural Genome to Phenome Initiative has shared. This one is enhancing discoverability and accessibility of UAV-based forage phenotyping hyperspectral data on CyVerse. It's a tutorial. Just a reminder, AG2PI is funded by USDA NIFA, and this particular workshop is an outcome of one of the seed grants that AG2PI has supported. So the lead presenter today is Dr. Zhou Zhang. She's an assistant professor in biological systems engineering in the College of Agriculture and Life Sciences at University of Wisconsin-Madison. She received her bachelor's degree in astronautics engineering and master's degree in instrumentation science and optoelectronics engineering from Beihang University in Beijing, China. She received her PhD in geomatics civil engineering at Purdue. And her research interests include satellite remote sensing, drone-based imaging platform developments for precision ag, multi-source remote sensing data fusion, artificial intelligence and machine learning in agricultural applications. I'm going to let a few more people in, and then Dr. Zhang, do you want to go ahead and take it away?
Okay, thank you, Nico, for the introduction, and thank you everyone for attending today's webinar. And now I'm going to share my screen, start my presentation. Is this good?
Looks great.
Okay, thank you. So today, myself and my student Jia Hao will be going to talk about enhancing discoverability and accessibility of UAV-based forage phenotyping for hyperspectral data. And we will be also sharing a tutorial how to share this data on CyVerse. So there are two major parts of today's presentation. One is the forage phenotyping project. I'll be introducing about forage phenotyping, the model we developed, and also the multi-sensor data we collected. And then Jia Hao will take on the second part to share the step-by-step guide for data publishing and sharing on CyVerse. So I will start with the first part, forage phenotyping. As many of you probably are already familiar with phenotyping, right? For phenotyping, we are aiming to develop, to have ways to quickly assess the crop phenotypes. For example, like leaf heights, crop yield, nitrogen content, water status of all these kind of phenotypes. But most of the research currently focuses on for green crops, and very little attention has been given to the forage crop, although it's also a very important crop in US. So in this project, we are targeting the forage crop. There are different types of forage crops, and in this project, we specifically target on maize silage, which is primary ingredient feeding for dairy cows, and also because I'm in Wisconsin and dairy cow, we are a big dairy state, so we have a lot of maize silage planted here. And there are also other types of forage crop like alfalfa, but in this work, we mainly focus on maize silage. But I also want to mention that the models we develop, the data and models we develop in this project could be applied to other agricultural commodities. So unlike green crops, for maize silage, we are mainly targeted on the yield as well as the quality values. For example, we can, at the end of the season, we can collect the dry matter yield, dry biomass, and most importantly, we are concerned about all these quality values like crude protein, starch, nutrition detergent fiber, NDF, and acid detergent fiber, ADF. For example, like this crude protein is important to tell how much nutritious content we have. And also this NDF, ADF determine the digestibility. So at the end, for phenotyping, because it's used to support breeding purpose, for the breeding purpose, we want to select breeding line, the variety that can generate the highest quality. So we have a summative quality criteria. We use this formula to calculate something called Milk 2006, because this was developed in this year. And then we combine all these quality values, CP, NDF in this equation, and then rank the numbers we get, then select probably the top 10 or very top varieties. So how can we assess those yield and quality values? So traditionally, we can definitely use some chemical methods, right? We collect the samples and send to the chemical labs. Alternatively, they started to use something called this near-infrared spectroscopy. It's kind of a desktop hyperspectral. It's also a hyperspectral data, but it does not have the spatial domain. So it's only like a spectral line or single domain. So for this NIRS is single point measurement and does not provide spatial information. But inspired by this technology, we have been thinking whether we can use some like hyperspectral image and use drone platform to fly over the field. Because if we need to use this, if we want to use this NIRS for the quality assessment, we have to collect the samples in the field for each plot, and we have thousands of plots. And then we have to dry the samples. And then we have to grind the samples into very small particles and then put into this machine, as you see here, very small area container here to hold the samples. And this process is very, very tedious. And also typically, people send this to some forage lab where they provide such devices to, and one sample can cost maybe $20. If we have thousands of samples, you can imagine how much cost there it is. So inspired by this, because they are both like hyperspectral wavelengths, we can collect information. So we thought about using hyperspectral imaging to fly over the fields and then collect data and then develop models. So maybe you know hyperspectral data already, but just a quick review. We unlike multispectral imaging or traditional RGB camera, they have like fewer bands, right? For RGB, we have only 3 bands, but for multispectral imaging, maybe we can have 5 or 7, usually less than 10 spectral bands. But for hyperspectral data, they have thousands and narrow spectral bands. So instead of seeing these individual spectral values, we see a more continuous spectral curve. And the hyperspectral imaging has a wide application in like precision agriculture, environmental monitoring, or food analysis. And also we can mount hyperspectral data on drone platform to collect data over farms. So from the hyperspectral data, we can have thousands of bands, but sometimes we don't need to use all the spectral bands. Then we can use some NDVI or other vegetation indexes to calculate the vegetation index. Because we have thousands of bands, actually we can calculate multiple or hundreds of different vegetation indexes. And then we correlate our image feature with the phenotypes and using machine learning models to estimate those phenotypes. Again, in the phenotypes, for the forage crop, here we are targeting on those forage quality parameters. Yeah, our project, we know the importance of hyperspectral data, but we also think other sensors could provide complementary information for us to the model development. So we also use this RGB imagery. And because we think the crop canopies can show some morphology variabilities due to chlorophyll fluctuations during the growth conditions. And this kind of information could be useful for our model development. And another sensor we use in this project is LiDAR. Usually for RGB and hyperspectral, they provide us the color information, but for LiDAR, they provide more like the geometry information. So like point cloud LiDAR, we can, and it can penetrate through the canopy layers. So we can kind of collect not only the top, but also the lower part of the canopy features. Then we think this could be linked to the above ground biomass. So this is the LiDAR sensor we used in this project. And then we have our field study area in Wisconsin in one of our agricultural research stations. And there's thousands of different breeding lines, varieties, forage there. So you see this is our study area, and usually the breeding crops for the plant breeding, the crops are planted very closely to each other, and the plot are very small. In this project, we have a 2-row plot. So like other UAV work, we need to collect data and also need to extract the plot level information and then further for the data analysis. And then in the quality values, we collect the dry matter yield, crude protein, starch, NDF, ADF. Finally, we combine all these individual phenotypic trees into this kind of summative equation to select the top varieties. And I would like to show this equipment we used platform. This is the M600 drone, and as you see here, there are 3 sensors mounted together. One, this is LiDAR, this is RGB, and the middle one is the hyperspectral, and we protect it using a box because that's the most expensive sensor. And this is a closer look at all these our 3 sensors. They are well integrated, and then on this altogether on this M600 platform. These are some detailed specs of all the our sensors, and we collect our data through the entire maize silage growing season. We use like every 2 weeks data collection schedule. So this shows the days after sowing. We started in the end of June until the end of August. So in here we have 7 flight time series data, and then we combine all this data together for the model development. And before we do the real data model development, we need to do some data pre-processing. This is the same process as all the other like UAV type of work, because especially for hyperspectral data, we need to do some data calibration. Radiometric calibration. Here are the 3 calibration target panels we deployed on the close to the field. They are 3 different colors with different reflectivity, 56%, 32%, and 11%. And then after the radiometric correction, we also need to do geometric correction, because you see here, these are different passes, right? Because we need to fly over different passes, and we mosaic them together. One thing we need to know, they need to have certain enough overlapping among different passes to make sure we would not have missing data between the passes. And then at the end, we mosaic everything together. This is the mosaic data. Also, we need to do some like soil background removal, and then cloud level data extraction. Then it's our modeling part. At the top, we have this 7-day time series UV data, multi-sensor data, hyperspectral, raw, RGB, and LiDAR. For each type of data, we need to go through a series of data pre-processing, and then we extract the relevant information from each type of data. For hyperspectral, usually we collect all the, we either use the vegetation indexes or use the original spectral band. For the RGB data, we usually extract some texture and morphological features. And for LiDAR, we extract some structure features. And then we develop our data samples into training set and testing set. Use training data to train our model, and then use our testing set to evaluate our model and report our accuracy. Of course, we need to collect some plot level field data. Usually we collaborate with our agronomy department. They help us collect this structures data for us to train the machine learning model. And then we propose a new model, which I will be introducing later, and compare our proposed model with some benchmark models, including both traditional machine learning as well as deep learning models. And this is our proposed model. So actually the novel, we have mainly a couple of novelties here in this model. One thing is that we combine all the time series data and all the sensor data, not only hyperspectral or LiDAR, right? We have all them. So it's a very big data set. And then we
तो हम चाहते हैं ये दोनों एक साथ.
Sorry, is there any question or what?
No, sorry, Joe, go ahead.
Okay. So yeah, we have this time series multi-sensor data, and we made it into this two-dimensional data. Why is this multi-sensor dimension? So in this dimension, we have hyperspectral, LiDAR, RGB. In this dimension, it's the time series data. So we have 7 here. And then we input this data into a feature fusion module. We use LSTM, which is a well-known deep learning module to help process the time series data. Also, we use the 1D ECN, which is a well-known deep learning module to help process the spatial feature. We forward this feature into a self-attention module to help extract the most relevant features. And then we use the final extract features and then to go through this two branches. One is to, as a regressional branch, we want to estimate the quality values as we have different quality values. One thing I want to further address is that actually we use a multitask learning framework because, as mentioned earlier, we have multiple quality parameters. Instead of developing one model devoted to each specific quality value, we kind of develop multitask learning models so we can explore the underlying relationship among different qualities. And then at the end, we predict all the qualities together. Also, we have a classification branch. So instead of predict each individual value, we kind of group them into different levels. Say maybe the top 10%, they belong to one class. Then we just separated them into different class, different levels of qualities. So this is our proposed deep learning model framework. And then we compare our model for different quality value predictions with other, the last one is our model with other deep learning models. And in most cases, our model, which are performed the best. This is our preliminary results. We are still fine-tuning our method to see if it can be improved. And then because we know the importance of data sharing and results sharing, so actually we collect all this hyperspectral LiDAR and RGB over entire season, multi-year data. We would like to share that with the public so you can develop your models on this data. So we know this data, usually a data commons platform needs to be used for data sharing. This is particularly important, especially for agriculture data sets, because due to the different types of data we need to use and the depths of the data involved. It can help support collaboration, definitely, and also promote this interpretability of the data. There are maybe different platforms, but one well-known platform and public is this called CyVerse. This is a National Science Foundation funded project which provides life scientists with this computational infrastructure to handle and sharing large data sets. This is the website of CyVerse. The CyVerse can help for sharing and reuse data. Also, however, it may be not very intuitive to use the CyVerse. So because of this downside, we developed this. We have this seed grant, and also we developed this tutorial to help researchers, even just maybe early career researchers, to know how to share this data on CyVerse. So based on this tutorial, I think you can have a very clear steps how to sharing and using CyVerse platform. That's the goal of this project. So the purpose of objectives of this tutorial, we break down the complex publishing on CyVerse procedures for our community, and we want to enhance our community engagement and improve our data discoverability, accessibility, and of course, we want you to use our data and to develop your model, maybe even just develop new models and test results. So we want to provide a clear and step-by-step guide. That's the goal of this tutorial. So now I will let my PhD student Jia Hao take over to provide a step-by-step guide for the data publishing on CyVerse. He will first go through each step, and at the end, he will do a quick lab demo to show how to share data. So just a quick introduction for Jia Hao. Jia Hao is going to start his third year. He already finished the first 2 years in our lab as a PhD student. His background, he has a computer science background. Also, he has like remote sensing geomatics background. Maybe I will let Jia Hao to take on. Maybe you can introduce yourself, more details.
Yeah,
and
sure.
I will start.
Actually,
sharing.
Joe and GL, sorry, before moving on, there were a couple of questions in chat. Do you think you can tackle those real quick before we get into the step-by-step for CyVerse?
Of course.
Sure. So
sure.
the questions have more to do with the data that you collected. Do you want to read them, or do you want me to read them for you?
You probably can read them.
Sure. Okay. So the first question is looking at historical LiDAR data. And the question is, how far back can they get historical data in LiDAR?
How far back? This is it a time? Sorry, can you repeat the question?
Sure. It's from Zawanda Mengwani. Sorry if I butchered your name. He says, my question is, how far back can I get the historical data LiDAR? I'm in the field of rangeland ecology.
We don't have historical LiDAR data. We collect our own LiDAR data. Because for this data set, we started maybe I can still, you cannot see my screen. We collect our data in 2021, and we continue collecting data in 2022. We collect our own LiDAR data. For a particular field, I don't think usually they are public available historical LiDAR data you can use. You have to use your own sensor to collect your own LiDAR data.
Okay, great. Thanks for answering that. One more question from Sammy. Is asking why by LSTM here. Can you please say some more detail? So you had a slide where you talked about the difference.
This is a bi-directional LSTM. Usually the traditional LSTM go from one direction. This is go to back and go to forward. So we can extract more time series features from this by LSTM.
Okay, great. Couple more questions and then we'll move on.
Sure.
So Moshood Bakari says, which package or library in R will you recommend for data quality control of hyperspectral imaging data prior to machine learning model?
I'm sorry, I could not really answer this because we never use R to process our data. We always using Python to process our data. Also, we don't use any existing libraries because, in my opinion, different libraries still target on their own specific data types. But just based on our data types, we just develop our own data processing pipelines. We are willing to share our data processing Python code to the public.
Okay, great, thank you. And last question. In the drone object detection, could you tell us more on the model used in the image acquisition, like the drone height, annotation tool, etc.?
Sorry, I forgot. in this project, we don't use any geo annotation tool because this is not really object detection. But if you want to do weed detection or other detection where you need to identify where is weed, where is crop, I believe there are some public available tools for do that annotation, but I just could not remember the name on top of my head. Jiahao, do you know any of those tools?
Let me. The drawn height used in object detection once we are using for weed detection. The altitude is around 8 meters, and for the data labeling, I think there is we use a label tool which is the same as YOLO. Do you guys know YOLO V4? We use YOLO, that model for object detection. They have a label tools in YOLO V4. We follow their labeling process, and the label tool is including YOLO V4. That is the object detection model. We modify that model, so you can explore YOLO, that model for object detection. Yeah.
Okay, awesome. Thank you guys so much for answering those questions. There's a couple more that popped up, but I think it'd be more appropriate to just answer them in chat. I think they're mostly asking for links to your works. Jiahao, if you want to go ahead and move on with the step-by-step guide.
Yeah, sure. Thank you, Nika. Hi, everyone. My name is Jiahao. I'm a PhD student now, work with Dr. Zhang. And my research interest lies in the intersection of computational agriculture and cutting-edge machine learning techniques, with a particular emphasis on deep fusion of multi-source remote sensing data and time series analysis, high-throughput phenotyping. And I'm glad to see you guys here. And now I will introduce our step-by-step guide for how to share and publish data via CyVerse in details, including how to use some tools to upload your files, to share your data with others, and also how to format your metadata, how to format your readMe file to increase your data visibility. And now I will begin. The first step you start with your journey with CyVerse is to create an account. One thing to mention here is that you need to use your educational email address or your institutional email address. Do not use Gmail or something like that, because if you use educational address, you will get a faster approval from CyVerse. And after their approval, you can begin your journey in CyVerse. So this is important. Use your educational address to get a faster approval. And then we got approval from CyVerse. Now you can log in the discovery environment of CyVerse, which is basically a web interface where you can manage and share and run your analysis. So you can find a lot of meaningful and well-organized data also in this discovery environment by using this search bar here. You can see here a lot of data shared by others. I can even see there is a AG2PI workshop, which is held in 2021. So here are a lot of interesting data sets shared by others before. So this discovering environment is a place where you can see the data store. You can use this search bar to search other data. And then we got approval for CyVerse. We can begin our journey to upload and downloading data. So now I will introduce this tool, which is CyberTruck. So this is CyberDoc. Yeah, this CyberDoc is a third-party software. Actually, you can upload your data or download other data via this software. Why we are using this software? Because surely you can use the web interface I just introduced, which is the discovery environment. But when you're downloading or uploading large files, the network connection may not be stable if you just use web interface. So it's good to have this software installed on your computer. And when you're downloading and uploading large files, this one is more stable. So from my experience, and then you can download this CyVerDoc from its official website, and you can choose the installation file according to your operation system. And the second thing is you need to download the CyVerse connection profile. This CyVerse connection profile is provided by CyVerse, and it's basically some server address and the port number configuration. They already write that for you, so you just download this one and open the connection profile. You can see we have two installation file, which is a CyVerDoc. You can just follow the wizard here all the way next until it is finished. And this is CyVerDoc. And then you open this connection profile provided by CyVerse. You can see the server address and also the port number already give you a port number and a server address. You just need to put in your username and password to start your connection. And one thing I need to mention is that use your username here, not the email address when you register your account. It's the username you specified in the registration process. So use the username and the password, not the email address. And then you can click more options to enable this multiple connections. It means if you log into the discovery environment, which is the web interface, when you connect to the server via this third-party software, it will not interrupt your connection of your web interface. So you can think web interface, you can log into while you are logging into this third-party software. They can be in the same time. So enable this multiple connections, which is important. And then we can connect to our account. You use your username, you use your password, and when you log into CyVerDoc, you can see here all the folders you created before, and all the subfolders you can explore. You can explore so it's a very nice and straightforward graphical interface here. And then from the file drop-down list, you can new folder. Let's say you have a new project, you need to upload the data and share with others. So you can, from this drop-down list, you new file and give it a meaningful name. And according to CyVerse, there is some naming conventions here you need to follow. So no special characters. No space, no special characters, just alphabet and underscore you can use for your project name, and follow the naming conventions, which is the creator, subject, and the project date. Like in my case, I have Jiahao underscore AG2PI underscore workshop underscore June 2023. And this is important for others to retrieve your data or search your data. And then let's say we need to upload some data to your newly created project. We can, from the file drop-down list, and select upload, and we can upload some demo data to try this software. And then we need to add a readme file for our data. Reading file is basically a file which located in the root directory of your project. it is the first thing when people download your data repository. So it is important to let others know how to use your data, how your data was obtained, and how you labeled your data. And so it is important. So we need to add this readme file in the root directory. You can see there is a pretty simple example of my data, and I just list how to use this file, how you can unzip this file, because our data is basically some images, hyperspectral images or RGB images or LiDAR points data. So it is more pretty straightforward. So I just list some simple instruction here, like the data specifications, the sensor specifications, and the folder inventory. It's good to have many subfolders of your project. Like me, I have 3 subfolders. Which folder have a different data source, and it is good as long as you specify your folder inventory here, like which folder and what is included. So this is a pretty simple readme file. And now we can add metadata to your folder, to your project. Actually, metadata is in CyVerse is basically something like the keyword of your paper, right? So when somebody want to search some data in the data store, like here, want to search some data, the keyword in this metadata is essential, because this is the keyword for their indexing. So make sure you add this metadata to increase your data visibility. And I will show you how to add metadata. You can log into your discovery environment, and you can see this data icon, and you click this data icon and go to your home directory of your user. In my case, the home directory is Jiahao, and you can click more action here, and you will see metadata. And when you click metadata, it will relocate you to a new tab, which is all the metadata here, because this is a newly created project, no metadata here. So we want to add some metadata to them. And fortunately, they provide some templates for us, which is a great ease. So you can click more action and view template here, and you can see this template list. Because we can request a DOI from CyVerse, we can use DOI for others. If others use your data, they will cite you, right? So that's a good thing. It's better to have a DOI. And in this case, we just choose DOI request dataset 4.1. This is the format for you to request a DOI if you want to be cited by others. So you click this one and select. And what is metadata? What is the field in metadata? Actually, there are some important field here, like the title. If you have a paper already published, you can use the paper title, and also to the creator, also your corresponding order, your PI, something, right? So I will show you later. I will show you a quick demo later, so you can see this file later. And this is just an example of my data. You can see this is my paper. This work is still under polished, so not published. I just see a question: did you publish this work? No. This work is still under work. We want to fine-tuning some of our work. So yeah, this is the title of our paper, and you can see here is a detailed description of our data, and also some project keyword here. Yeah, actually, when people want to search some data in this data store, all these keywords will be used to increase your data visibility. And I need to stress, double check this thing. Like once again, no space or special characters in your project name, and make sure you include a readme to tell others how to use your data. And also you need to follow the naming conventions and you need to add metadata. Like if you want DOI request, DOI from CyVerse, you choose DOI request, and at least you need to fill in 3 fields of the metadata. And one more important thing is that if you submit the DOI request to CyVerse, you cannot change the data anymore if the DOI is issued to you. So make sure your project data is in perfect shape before you submit your DOI request, right? So nothing. If you really need a DOI, you need to pay them, right? So you need a DOI. You at least need to pay $200 a year. So it will give you 5, at most give you 5 DOIs for you, and 5 projects, 5 DOI, and others can send to you. And it's good to share your data with the community, right? Because we can measure collaboration, we can increase our collaboration, and then improve our community. So yeah, and you can upgrade your plan in the homepage of Discovery environment. You can see your current subscription, and you can buy. So after that, you can request DOI. And I will show a quick demo here. Quick demo how to do this. At first, this is a Discovery environment. Can see my screen, right? So yeah, this is a Discovery environment of CyVerse, and you need to download this 2 installation file. This one is the CyberDoc. You just follow the wizard to finish this installation process. And I have installed the CyberDoc, so I just skip this one. And then you double click it to open this connection profile provided by CyVerse. And when you double click it, this window will pop up. You can see already the URL, the server, the port number already fixed, right? You cannot modify this too. So it's just a configuration file provided by CyVerse, and you type in your username and password. And once again, you can enable multiple connections, right? So this is a configuration of CyberDoc. And after that, you will have this. And you can connect to the server, like I already have my account here. When you connect to your server, you see your home directory here, 3 folder here. Now I want to upload some data, right, to a new created project. So a file drop-down list and a new folder, and follow their naming convention, which is creator underscore, and your topic, I will say AG2PI, and task, and date 2023. Okay, this is the folder. Okay, I have a project folder here, and here you can still create some folder to have subfolder, right? Like me, I have LiDAR RGB Hyperspectral. And let's just demo this process and just upload a simple file here. I will upload this slice, which is the hybrid. It's a genotype used in our experiment. I just choose this one. And it's really quick because it's a small file. Yeah, it has complete. So when you come back to your Discovery environment, you can see this one is already here. And the next step, you write some detailed README file, like how to use your data inventory. So upload your readme file, just like this one, readme txt, and upload it to the root directory of your project. And then you reload your project. You can see the readme file already here. And here you can see this is our newly created project. And now let's add some metadata to it. You can see here is more action. You can see metadata. There is no metadata because it's a newly created project, and you can see more action here, and you will in template, and you select this DOI request, right? And select. You can see this is all the fields that you need to fill in. You can see a star here, which means there is the required one. The title, creator, application, and publication year, contributor, description, subject, which is the keyword, and right, all this metadata you need to fill in, right? You can explore, and I just cancel here. Right. So after this, and when you can upgrade your subscription. You can buy more space, and also when you upgrade your plan, you can request a DOI from CyVerse. And see, I will just choose this one, more action, and request DOI. That's it. And if you are just using a free version, you don't want to pay them, right? You don't want to DOI for them. You can still share with others. You can still like go to your folder. Like let's say I want to share my data, my hybrid, my genotype of the hybrid in my data to more action public links. Right? You can still share with others, just like Google Drive, right? If you have a good metadata, good readme file, others also can see your data from this search bar. If they are searching some keyword like high-throughput phenotyping or AG2PI, they can still see you. Okay. Yeah, this is the quick demo of this project, this step-by-step guide, and we believe this tutorial will help our community to increase our collaboration and also our data visibility. And data is important, and we can share our data through this great platform. And I'm here for some questions, and otherwise, have a good day.
Thank you, Jiao. I'm not seeing any questions right now in chat, but if anybody has a question that they'd like to share, you can either put it in chat, or since we're towards the end here, you can also just unmute yourself and ask. As I was saying this, there is a question that just popped up in chat. Ed Barnes is asking, can you show the screen with the upgrade options and prices again, please?
Yeah, sure. They have like to your main account, and you can see your subscription here. You can just buy, and they have different options here. Actually, I have a slide which is more clear. You can see you can have 5 DOI for $200, and you will have more data storage limit, which is 50 gigabytes. And you can upgrade to Pro and commercial, more DOI, more space. but more expensive, right? Yeah. Could you please share the recording? There are areas I would like to revisit. Yeah, I think Nico can.
Yes, this will be up on the AG2PI website, if not by the end of the day, then by tomorrow. We share all of our recordings. So you'll just go back to the same webpage you went to register for this event.
Okay. Another question. What type of data does CyberDuck support? What is the maximum the size of data that we could upload? Is there any limitation on access or something? No, first, there is no no limitation on CyberDuck. You can donate them, but yeah, it's a free software. It's an open source software. You can donate some money to them, but it is free, no limitation. And what does the CyberDuck support? What kind of data? All kind of data, like you can zip your data into a zip file. They support a zip file and images, all kind of data. What maximum the size? If you are use a free version of CyVerse, this CyVerse, this is server, right? Not a CyberDuck. This server, the limited is 5 gigabytes, right? I'm a little confused if we can use CyVerse for data integration platform or only a data sharing platform. Data integration platform. I don't get what do you mean by integration platform. But you can store your data in CyVerse. You can still store your code in CyVerse, and CyVerse it itself support R language to programming. They have the integrated IDE for running your R code, but I'm not sure what integration platform here. Can share your data. You can analyze your data. You can still share your workflow, your Python code, your R code with others. Yeah, is that answer your question? Okay.
Okay,
Yeah.
any other questions? Again, you can type them or you can just go ahead and unmute yourself. We've got 5 minutes left. If there are any remaining questions out there. Yes, Sammy, go ahead and unmute and ask. That's fine.
Thank you. So I have like another confusion. Sorry for that, but I need to ask. The thing is, like you showed in your first few slides that you are using some machine learning and deep learning models for identifying something or predicting, but now I'm a little confused. Like why are like how are you like merging those two, like CyVerse and those deep learning models? Are you like doing something in that platform, like inside CyVerse? Are you deploying those models in CyVerse for generating the data to share?
Thank you for your question. That's a good question. Actually, no, we didn't deploy our model on CyVerse. We talked about our research because we want to show our data can enable a lot of innovations. The data is very useful to reveal some new discoveries. So that's why we are introducing our research. But we just want to let you guys to show you guys like how to share data with others. We didn't deploy our model. Yeah, that's a quick answer for your question.
We still have time for another question if there are any remaining. Not really seeing any. I'm going to do a couple of housekeeping things. So if you do have a question, feel free to go ahead and type it in the chat. But tomorrow we do have an AG2PI field day. It is on data encryption. So if that's something that is interest to you, it is from 10:30 a.m. to noon US Central Time. You can go to the AG2PI website to register for that. Again, a recording of this workshop will be available on the AG2PI website, again, on the event webpage, and it'll probably be available by tomorrow at the latest. Seeing that there are no further questions, thank you all for attending. Thank you, Zhou and Jihao, for sharing your work with us. Very much appreciated. And again, AG2PI is funded through USDA DFA, and this particular workshop is the result of an AG2PI seed grant.
Thank you.
Thank you.
Thank you.
Everyone have a great day.